For today's MCAS topic, we're talking about equations of lines. We're going to run through a number of different topics within equations of lines. Hopefully a lot of it will be review. So the first is we're going to talk about linear equations. So linear equations come in a number of different forms in terms of the equations themselves. So the most familiar one is probably what we call slope-intercept form, where m represents the slope and the y-intercept is b. So this is y equals mx plus b. Now this is the one that probably you're most familiar with, but there are also other forms of a linear equation. They don't have to be in this form, y equals mx plus b. So another form is what we call point slope form. And this looks like this: y minus y1 equals m times x minus x1. Now this form is useful anytime, as the name suggests, you are given a point and a slope, because you can plug in the slope m, and then you can plug in the point that you're given into x1 and y1, which will leave you with an equation just in terms of x and y. Now lastly, finding slope, if you are given 2 points that are on a line, you can find the slope of that line using this equation. So y2 minus y1 over x2 minus x1. Now it doesn't matter which of the 2 points you make x1, y1 or x2, y2, as long as you're staying consistent and x1 goes with y1, x2 with y2 when you're labeling those points. All right, we'll take a look at this first example. So it says points -2, 4 and -1, 1 lie on the same line. Determine the equation of the line. So we're given 2 points that are on a line. So the first thing we're going to do is we are going to solve for the slope first. And once we have the slope, then we can use point slope form and find the equation of that line. All right, so slope, remember, is y2 minus y1 over x2 minus x1. So that would be 1 minus 4. And then in the denominator, be careful with your signs here, that's going to be -1 minus -2. Okay, so that leaves us with -3 in the numerator. And in the denominator, we have -1 plus 2, which is equal to +1. So -3 over 1, which is simply -3. All right, so now we have the slope. So now we can, remember, we're trying to find the equation of that line. So we're going to use point slope form. And why? Because we're not given the y-intercept, so that might not be the easiest form to use. But however, we do have the slope, and we do have 2 points actually. We don't need 2 points, we just need 1. So we're going to go ahead and plug in -3 for m, the slope, and then I'm going to go ahead and use -1, 1 for x1 and y1. So that's going to be y minus 1 equals -3 times x minus -1. So x minus -1 is x plus 1. Now you could leave your equation just like this. That would be perfectly fine. If you were asked to write it in slope-intercept form, or if you're more used to it in slope-intercept form, or you might be asked to graph it, it might be easier to work with in slope-intercept form. So to get this into slope-intercept form, all we need to do is distribute that -3 and then add the 1 over to the other side. And that would be equal to y equals -3x minus 2. And that would be our equation in slope-intercept form. All right, next, let's talk about slope in general. So in general, we have ways of describing slope, even if we don't know what the exact slope is. In this first one, we can see as you're moving from left to right, that line is increasing. And so we call this a positive slope. In the second one, as we're moving from left to right, we see that we're decreasing. So we would call this a negative slope. And then in the third one, we see we have a horizontal line. Anytime you have a horizontal line, the slope is 0. And then the last one, we have a vertical line. And anytime you have a vertical line, we would say that that slope is undefined. And the reason why we have an undefined slope, you can imagine if we're applying that equation y2 minus y1 over x2 minus x1, your x values are going to be the same, which leaves you with a 0 in the denominator, which gives you an undefined slope. All right, another thing to talk about are parallel and perpendicular lines. So the two things to remember are that for parallel lines, they are going to have the same slope, and perpendicular lines will have slopes that are opposite reciprocals. Now, it's important to have both of those words because those two words mean different things. So the opposite meaning if one has a positive slope, the other has a negative slope. Reciprocal meaning you take the numerical value and you flip the fraction. So say that one line had a slope of 3. The reciprocal of 3 is 1/3. Okay, so if it's the opposite reciprocal of 3, that would be negative 1/3. All right, let's take a look at an example here. It says, find the equation of a line that is perpendicular to the line y equals 1/2 x minus 5 that contains the point 1 comma negative 4. All right, so first we take the line that's given to us and it has a slope of 1/2. Now, if we're trying to find a line that's perpendicular to this one, it must have a slope that is the opposite reciprocal. Now, we actually don't care what the y-intercept of the line given to us is. We only care about the slope. So the opposite reciprocal of 1/2 would be negative, and then flip the 1/2, and that would be 2. So negative 2 would be the slope of a line that's perpendicular to this one. All right. So this is what we have so far for the equation of our line. Y equals negative 2x plus b. We don't know what the y-intercept is. But that's where the point that's given to us is going to come in handy. We're going to use this point 1, negative 4, and we're going to plug those values in for x and y, and that will leave us with just b left in our equation to solve. So this is going to be negative 4 equals negative 2 times 1 plus b. So that's negative 4 equals negative 2 plus b. Add 2 to both sides, and that leaves us with b equals negative 2. And so now we can write the equation of our line. We said the equation of this line would have to include the fact that we have a slope of negative 2, and we actually just found that the y-intercept is also minus 2. So y equals negative 2x minus 2 would be the equation of this line. All right. Last thing we're going to talk about are lines of best fit. So when we talk about lines of best fit, there are a couple things to keep in mind. So first, if you're given a scatter plot and the line of best fit is not drawn in, you should go ahead and draw one in. Generally, when you draw in a line of best fit, as the name suggests, you want to be able to draw a line that best represents all the data in your scatter plot. So one rule of thumb is to try to draw your line such that it has the same number of points both above and below that line. All right, once you've drawn that line of best fit, you'll determine the slope of that line that you drew and the y-intercept. So that way you have an equation of a line to work with, right? You have the slope, you have the y-intercept, then you have an equation of a line. And typically you'll use that equation of that line to help you estimate an answer. Depending on the question, it might ask you, based on the line of best fit, what would be the best estimate for this particular value of x? All right, so let's take a look at our last example. So it says the scatter plot shows the relationship between the outside temperature at noon in degrees Fahrenheit and the number of drinks sold in a park. Based on the line of best fit for the scatter plot, what number of drinks is expected to be sold in the park when the outside temperature at noon is 95 degrees Fahrenheit? All right, so there's no line of best fit that's drawn, so we'll start off by drawing it. So again, do your best to try to draw a line such that it's really in the middle of all of that data. So I'm going to try to draw it so that you have about the same number of points both above and below. If you can go through as many points as possible, that's great. It's probably something like this. All right, and then once you have that line, now you could come up with the slope and the y-intercept to help you come up with an equation of a line. But here, actually, everything is already kind of labeled for you. So in this problem, it's asking you, what number of drinks is expected to be sold in the park when the outside temperature at noon is 95 degrees Fahrenheit? So let's take a look. So when the temperature is 95 degrees Fahrenheit, so you're looking along the x-axis here, what is the number of drinks expected to be sold? So that's your y value. So basically, what is the y value when x is 95? So based on our line of best fit, it looks like it's somewhere between 300 and 400. So in this multiple choice problem, we can definitely rule out A and D. So now it's between 325 and 385. Now based on our line, it looks like it's a little bit closer to 400 than to 300. So I would say 385. Now if ever you're not quite sure exactly, I would write the equation of the line and plug in x equals 95 and see what we get for y. But in this case, we probably have enough to say that our answer here is going to be C, 385.